In this video, we will demonstrate how to apply the binom.dist formula in Excel to calculate discrete and cumulative probabilities based on the binomial probability distribution. In this example, we have a new acne medication which is claimed to be 80% effective. A sample of 15 people are using the medication. In the first case, we are asked to determine the probability that all 15 participants will see significant success from using the medication. The binom.dist function in Excel makes it easy to solve this type of probability, but it is critical to know all the variables that go into the function. I've pasted in an image of the dialog box. Let's go through the first question and walk through the dialog box. Equals binom.dist, open parenthesis, and then clicking the FX button. Let's go through the first question and walk through using the dialog box. Our first question asks for the probability that all 15 participants in the sample will show significant improvement. We are therefore looking for the probability that the number of successes equals 15. Number underscore S is the number of successes we want to determine the probability for. In this case, that would be 15. Trials is the number in our sample. In this case, that's also 15. Probability underscore S means the probability of success, which is believed to be 80%. You can enter 0.8 or you can enter 80%. Cumulative can either be set to true or false. If I enter true, it means I want the probability up to and including that number of successes. False means I want the probability of getting exactly that number of successes. For this problem, I would therefore set cumulative equal to false because we are looking for the probability of exactly 15 successes. Once I enter false, the answer shows in the dialog box. I'll go ahead and click OK, and we see 0.035 or 3.5% is the probability that all 15 participants will see significant improvement by using the new acne medication if it has a probability of success of 80%. The next problem asks for the probability that fewer than 9 of 15 will show improvement. In this case, we care whether 1 or 2 or 3 or up to 8 people, but not 9, show improvement. This is a cumulative equals true problem. This time, instead of the dialog box, let's enter the formula directly in the cell. Equals binom.dist, open parenthesis, and it tells us first enter the number of successes that you care about, and I will enter 8 because we care about less than 9. Next, I'll enter 15 for the number of items in our sample, which is also considered the number of trials. The probability is 0.80, and I'll set this to be true. Close parenthesis and hit enter. The probability is just under 2% that fewer than 9 people will show significant improvement. And finally, what is the probability that 12 or more will show improvement? When we use cumulative equals true, Excel returns the probability of x less than or equal to some number of successes. We need a way to determine greater than or equal to. For that, we can use 1 minus the binom.dist formula, setting cumulative equal to true. These are whole number variables. Therefore, if we use 1 minus the probability of 11 or fewer successes, we would find the probability of 12 or more successes. Equals 1 minus binom.dist. My number of successes here is 11 because we're going to set cumulative to be true, which will tell me the results of up to and including 11. 0.8 for the probability and true. Close parenthesis, and the probability is just under 65% that 12, 13, 14, or 15 will show significant improvement. In this video, you have learned how to apply the binom.dist formula to determine discrete and cumulative probabilities using a binomial probability distribution. In this video, I'll demonstrate how to use the hypergeometric probability distribution with the Hypergeome.Dist formula in Excel. The hypergeometric probability distribution is used when we have two possible outcomes, success and failure. However, unlike in the binomial probability distribution, the probability of success changes for each trial because we are sampling without replacement. In this example, a law firm is considering moving its headquarters from Ohio to Kentucky. There are 10 partners in the firm, 7 of whom live in Ohio, 3 of whom live in Kentucky. If the law firm will randomly select 3 partners to serve on a committee to consider moving the headquarters, what is the probability that one member of the committee will live in Kentucky? If we only wished to know what is the probability that the first committee member lives in Kentucky, that would be 3 out of 10, or 30%. However, we're going to select a committee member who has a 30% chance of living in Kentucky. Then we'll select another from the remaining pool of 9 candidates. And if our first committee member lives in Kentucky, then that leaves a 2 in 9 chance that the next person will also live in Kentucky. Notice how the probabilities are changing and the problem becomes more complex. The formula for the hypergeometric distribution is based on counting formulas. In Excel, we can use the Hypergeome.Dist formula instead. It requires 5 components. Let's walk through the first question about having exactly one member of the committee living in Kentucky, and we'll see how to apply the dialog box to solve this problem. In this cell, I'll type equals hypergeome.dist and then fx to open the dialog box. Sample underscore s is the number of items that I want to have as a success. In other words, I want to calculate the probability of having this many successes in my sample. Because I'm looking for the probability that one member of the committee lives in Kentucky, I put a 1 here. Now there's the number in my sample, which is 3. I'm going to pick 3 people from the partner list randomly to serve on the committee. Next, we look at how many members of the population demonstrate the characteristic or attribute we care about, which in this case is living in Kentucky, because we're counting a success as a committee member lives in Kentucky. 3 of the population live in Kentucky. The total of the population is 10 partners. And finally, we consider cumulative to be either true or false. We'll use true if we wanted it to be up to and including 1, false if we want it to be exactly equal to 1, as we do in this case. You can see that the answer is already given in the dialog box. I'll click OK and it will insert the answer into the cell. There's a 52.5% probability that exactly one of the partners on the committee will live in Kentucky. The next question asks, what is the probability at least 2 members live in Kentucky? We want to know the probability of 2 or more. For this one, we will look for the probability of 1 or fewer, and we'll subtract it from 100% in order to find the probability of 2 or more. Let's compute that directly in the cell. Equals 1 minus the hypergeome.dist, open parenthesis, and it tells us all of the items that need to go into the formula. We'll put a 1 here. The number in the sample is 3. The number of people who have this characteristic in the population is 3 out of the 10, and we're going to run this as a true. The probability of 2 or more members of the committee living in Kentucky is 18.3%. This video has demonstrated how to use the Hypergeome.Dist formula to apply the hypergeometric probability distribution. This video will demonstrate how to apply the Poisson distribution using the Excel formula Poisson.Dist. The Poisson distribution like the binomial and hypergeometric probability distributions, has only two outcomes, success and failure. In this example, a loan officer at a bank approved 40 loans last month. Based on many years of experience, the default rate, that is, the rate at which people will not be able to repay their installment loans, is 0.025 or 2.5%. We are seeking to answer two questions: the probability that 3 loans will default, and the probability that 3 or more loans will default. This is the dialog box for the Poisson.Dist formula in Excel. Note that we only need 3 pieces of information. First is x. What is it we are seeking the probability of? In the first question, we're seeking the probability that exactly 3 loans will default, i.e., p of x equals 3. The mean is the expected number of loans that will default in that interval. Since we know 0.025 is the default rate, and the loan officer made 40 loans, then 0.025 times 40 equals 1 loan. The cumulative value can either be true or false. True means we are seeking the probability up to and including some value of x. False means we are seeking the probability of x equals some value. For the first question, we will use false. Let's open the dialog box, enter our information, and solve the first question. Equals Poisson.Dist, open parenthesis, f sub x to open the dialog box. Here we are looking for the probability that 3 loans will default, and the mean, which we can calculate in the cell, is 0.025 times 40 loans, given in 1 month. Cumulative will be false because we want to know the exact probability for 3 loans defaulting, and that probability is just over 6%. The next question asks, what is the probability of 3 or greater loans defaulting? So we are seeking greater than or equal to. Cumulative will tell us less than or equal to. We can find the probability of 2 or fewer loans in default, and then subtract that from 100%, which will tell us the probability of 3 or greater being in default. Let's compute it directly in the cell. Equals 1 minus Poisson.Dist. The x we care about here is 2 because remember we're going to do 2 or fewer and subtract it from 1 to get the 3 or greater. The mean is still 0.025 times 40, so this is 0.025 of the loans in a month, and then true. And the probability is 8% that at least 3 loans will default. This video has demonstrated how to use the Poisson.Dist formula to apply the Poisson probability distribution.